Hello, mathy people. Have you ever been faced with an opportunity where somebody hands you tools and says, these are really helpful and this will really help you out? And you look at them and you just wonder what in the world is even going on. Nobody's given you this basic tutorial. Nobody's told you what they're about. I remember feeling that way about algebra tiles, and I tried to learn many times. People tried to show me how useful algebra tiles were. Here I want to tell you some of those basics that I had to learn the hard way so that you don't have to learn them the hard way. Let's talk about the basic ideas of each of these algebra tile tools, how to use them, why they're useful, and how to do the different operations with them. This is math teacher Barbie, and we're going to talk about these algebra tiles and the very basics. So the first thing you need to know is that the individual tiles represent the area that they cover. So I have here a yellow tile that is 1 unit long by 1 unit wide, and it represents 1 square unit. And so we can see that 1 in there. Right next to it are two other tiles, the X and the Y. And so for the X, you might notice that it is X units long and 1 unit wide. So if I multiply the width of 1 times the length of X, I get 1 times X, or X. And then Y is similar. It's Y units long, 1 unit wide, 1 times Y is Y. X squared, X units long, times X units wide. X times X makes X squared. Y squared, Y units wide, Y units tall. Y times Y is Y squared, and then X times Y, it's Y units wide in this case, and X units tall. So we get this X times Y area. So each of these squares represents the area of the space that it covers. Let's not worry about the pink ones with the negative signs quite yet. Each of these is the area of the number of squares that it covers. Now, one thing I want you to note, this X here, we could estimate how many ones it is. I want you to pretend that you can't do that we can't even estimate the length of X. We're just going to sort of just pretend that that's not even happening. It's a limitation of using a physical representation, is that we do have to choose a length for it to be. So we're going to pretend like we can't even estimate that physically. So X is however long X is. We're not even going to try to count how many units long X is. We're just going to say, we don't know what X is. We don't know what Y is. We're going to leave that be. The next thing we need to know is that when we combine tiles, that we can take these tiles and we can combine them together. Let's make some copies. So we have 1 and an X, and if we just combine them together, we get X plus 1. So when we just accumulate them, we might set them next to each other, we might set them apart, but if we accumulate a group of them, this is like totaling them together, we have X plus 1. And in fact, in this case, now we have one big bar that's X plus 1 long and 1 tall. So 1 times X plus 1 makes X plus 1. And we're going to use that then, we're going to build that up into multiplication. But for right now, if we're just accumulating tiles, let's get an X squared in there. So if I have X squared, let's say I have X squared and 2 of these X's plus 1. This is going to be X squared plus an X plus another X plus 1, or x squared plus 2x plus 1. So I can represent these plus signs just as gathering up and accumulating these tiles. That's addition. Addition means combining these tiles together. If I have that and I want to add another two polynomials together, I'm going to make each of those polynomials, and then I'm just going to put them in one big group and count what I have. So addition is just gathering them up and counting how many you have. Next, multiplying. If we want to multiply, we're going to go back to that area model of multiplication. We use that same area model to talk about at the beginning of how each shape represents the amount of area that it covers. Well, that area model is going to come back into play. Now, if you're not familiar with the area model, I'll link my area model video in here as well. Let's say I want to multiply x plus 1. So we saw x plus 1 already. Let's just multiply x plus 1 times x plus 1. What I'm going to do is I'm going to take my algebra tiles and I'm going to set them up as the sides of a rectangle. In this case, it's a square, but I'm going to set them up as the sides of the rectangle. So in multiplication, what we need to do then is we need to fill in the rest of this rectangle. Here's our rectangle we need to fill in. We need to fill it in with blocks. We have an x times an x, that's going to be an x squared. We have an x times a 1, that's going to be another x. We have the across x times this 1, that's going to be another x. In order to fit it in, we've got to turn it sideways, and then we have a 1 times a 1. And again, this is just that area model. We filled it in, so now we have this x plus 1 on one side times x plus 1 on the other side. It gives us x squared plus x plus 1. X squared plus 2x plus 1. We saw that once before. Then if we want to factor, factoring is just unmultiplying, so we're trying to figure out what the sides are. So we're going to use the same idea when we're factoring. We're going to set it up as a rectangle or a square. We're going to put them together, and then we're going to figure out what sides make that happen. So that's the idea of multiplying. And multiplying is going to rely on that area model. Now if I want to subtract x squared plus 4x plus 3. I'm going to take that whole thing and I'm going to subtract 2x. Subtraction we can either think of as taking away, or we can think of as adding the opposite, and they both work. So if I want to subtract 2x, I'm going to set up my x squared plus 4x plus 3, and I'm going to just take 2 of the x's and take them away. So now what I have left is an x squared. I have 2 x's plus 3 right in this group. So I can think of subtraction just as taking away. Now, there's another way that I could think of this, and that is as adding the opposite. And that's what these red tiles here are for. So if you have physical algebra tiles, they'll often be the other side of the tile. You just flip the tile over. It's usually red for the negative. We go with the accounting and economics color coding. If you're more familiar with batteries and cars, then this might feel backwards to you. But negative is usually associated with red in academics. So here we're going to have plus negative 2x. So we're going to think of this instead of minus x, we're going to think of it as plus negative 2x. So x squared plus 4x plus 3 plus negative 2x. So we're going to take a negative x, let's take 2 of those negative x's, and we're going to bring those over here. We're going to add those into this group. You add them wherever you want to add them, because that's the thing with addition, right? Is you can add them wherever you want to add them. And that then leads us into item 5, that we're going to use 0 pairs when needed. So what happens when I have a positive x and a negative x? And here, these electronic algebra tiles have a really lovely little component where if I combine them, if I move them over each other, they turn to a 0. Now, if you have physical algebra tiles, you can't do that. You have to know that they turn to 0. But here, in these electronic ones, I can see my zeros. And that 0 is just made up of a positive x and a negative x. They subtract out. So this is what we call a 0 pair. We're going to use those 0 pairs. Now those are zeros. We don't have to write zeros. And I end up again with x squared plus 2x plus 3, just like I did before. Now sometimes when we're trying to make rectangles out of things or whatnot, sometimes we're just going to want to create intentionally these 0 pairs. So there will be times that come up where we intentionally need a 0 pair, and we're going to have to create that 0 pair to make it work, to give us 4 of these x's. Maybe we needed to add some zeros. So if I have this x squared plus 2x plus 3, maybe I need 3 positive x's in there. I need a positive x for every unit. But this comes up periodically in different situations where we might need to add a 0 pair. So you're just going to pick an algebra tile and its opposite, the ones that will make it work. You put them in, it's like adding 0, and then you can manipulate these tools, and you can watch those other tutorials to figure out how to do that. These are the very, very basics of the algebra tiles. I hope that was helpful, and you've got this.